So, some of this stuff I'm going to go through slowly. Some of it I'm just going to fly through. These are just rules of exponents from algebra. You should know that, right? This is a common error that when you have a sum or a difference, that students just square the a and square the b. That doesn't work, does it? So what's the only correct way to handle something like a plus b squared? What's the only correct way to handle that? Write it twice and then FOIL, right? Got it? Okay. So just make sure you don't make that mistake here. And obviously when you have a product, it's as simple as just, you know, raising the a and the b to the power. Same thing with a quotient, right? I mean, it's just a matter of, you know, raising the numerator and the denominator to that power. But for a sum or difference, it doesn't work that way, correct? Okay. You should be really good with radicals. Okay, everything I'm going over today will show up in every chapter. I'll tell you right now, without being algebra experts, you guys will not make it through the course. Because oftentimes, AP Calc problem will be one step of calculus and about 10 to 15 steps of algebra. So that's, the algebra is the hard part. Okay, so that's why I'm taking all the time here to review everything about algebra I need you to know going forward. Okay, so if you have something raised to a fractional power, you should know how to convert that to radical form by making the denominator the root and making the numerator the exponent, like that. Another powerful thing you can do is if you have a power inside the root, you can pull the power outside and then just take the n through to a and worry about the power at the end. That again, that sometimes makes things much, much easier to work with. Okay, so you should know that. You should know you can split up a product like that into separate roots. Same thing with a quotient. But do not do it with a sum or difference, okay? You cannot split up a sum or difference like that inside of radical into that. That does not work. Is that clear? So you got to know what you can do and you got to know what you cannot do. With me, guys? Okay? All right. Here, obviously you know that. That's just distributing. This is just getting a common denominator. So what I did here is I got a common denominator, right? And then turn this into that with a common denominator, right? Okay? All right, now something like this, okay? There's a couple ways to handle that. By the way, that's called a complex fraction because it's a fraction inside of a fraction. One way to handle that is just flip the c over d and then multiply, right? That's one way. However, when these get really nasty, you're not going to want to do it that way. You're going to want to do it this way instead. So what was the trick I did here? What did I do to the original problem? I multiplied the top and bottom by what? I multiplied the top and bottom by what? BD. What's BD? The what? It's the common denominator, isn't it? Right? I don't like that highlighter because it's... Is it hard to see when I highlight something in blue in the back? Is it hard to see? Can you still see it after I highlight it? Okay. All right. So anyway, so by multiplying top and bottom by the BD and simplifying, it turns into a nice fraction that I can work with from there. So that's a little trick I want you to know, okay, to clear out a complex fraction. Okay. All right. These are kind of more of the same. Here's a little trick I want you to know. How do you simplify something like that? Suppose, again, a lot of the questions on the test are going to be multiple choice, or you might be checking a homework problem in the back of the book and you get that answer, but your answer looks different. Well, there's a way you can simplify and rewrite that. Well, maybe not simplify, but rewrite it in another way. So what did I do here? I pulled out a what? A negative on top. I pulled out a negative on the bottom, and then I canceled the negatives. And then what's negative a plus b the same as? B minus a. So by pulling out a negative and canceling them, I was able to turn that into that. Does that make sense? So if you have that as an answer instead of that, you should know that they're the same thing. Are you clear on that? Okay. What did I do here? Well, how do I turn a plus b over c into a over c plus b over c? Well, if you don't see how that works, think backwards. All I'm doing is taking two fractions that have a common denominator and adding them, right? So if I go from here to there, if that makes sense, then going backwards should make sense, right? So if you're not sure how that works, just look at it backwards. And then from here on out, when you see this, I want you to turn it into the a over the c plus the what? b over c. But be careful. I know what you're going to do. You're going to take that and say, oh, well, if that works, then I can turn this into this, right? Wrong. It only works when the sum or difference is on top and there's one term in the bottom. That's the only time you can use that trick. Is that clear? You understand that this does not work, but this does, right? It's going to come up all the time. You got to know that. Okay. And here, please be careful. Why can't I cancel the a's there? Why doesn't that work? Because that would need to be a what? That would need to be a what before I could cancel the a's? A multiplication. That would be the only way I could cancel those a's. Is that clear? Okay, so be careful on what you can't do as well as what you can do. Okay, what am I doing here a bunch of times? I'm what? I'm taking, how do I make a negative exponent a positive exponent? I do what? I move it from the what? Yeah, from the top to the bottom or the bottom to the top. Isn't that how I get rid of a negative exponent? Okay? So I gave you a bunch of situations. I want you to say true or false here. So hopefully you did that. Okay, I don't have time to go through each of those, but you should be able to do that. Okay? All right, simplifying a radical is a necessary skill, absolutely, for calculus. So you can only simplify it when that number is greater than or equal to that number. Okay, so once you realize you can simplify this, how do you do it? Well, there's a couple ways. The bottom line is, when the root and the exponent match, they cancel out, don't they? So what I did is I broke up x to the 10th into as many powers of 3 as I can. So I broke it up into x cubed times x cubed times x cubed times x to the first. Now wait, why does that work? Well, again, what's the algebra 1 rule when you multiply all those x's? What do you do to the exponents? Add them. So do you agree they add up to 10? Do you see why I can break it up like that? And then what did I do? Then I used the property I just mentioned to break it up into what? A bunch of separate radicals, right? And then the 3's cancel there, giving you an x. The 3's cancel there, giving you an x, and so on. So in the end, I have an x times an x and x, which is x cubed. And that just turns into cube root of x. Same thing, right? Got it? Again, unless you're able to do this, you won't be able to use calculus. And if you can't use calculus, then what's the point, right? Okay. Now, there's another way you might like better. First of all, I wrote that as that, right? 10/3 is the same as what, guys? 10/3 is the same as 3 1/3. And then how can I break that up? Well, again, do you agree I can break that up into that? Because, again, what's your algebra 1 rule when you multiply the x's there? You what? Add the exponents. What's 3 plus 1/3? 3 1/3. So that might look awkward, but I can do it. It does work, doesn't it? Okay, and then what's another way I can write x to the 1/3? Cube root of x. So do you agree I get the same answer either way, using either method? I don't care which way you do it on the test on Friday, but there will be some of those on the test. You got to be able to handle that. Got it? Okay. And so after I did 16, you should be able to do the rest of these here. Okay, I don't have time to go through those. What did I do here to simplify that nasty looking thing? You're going to have to do it. What did I do? Take a look. I didn't make you write it down. I typed it up for you. What did I do? Turn that into that, right? How did I turn that into that? By what? How did I make that a positive exponent? By moving this whole thing where? To the bottom. And then I turned x to the 3/2 into what? Square root of x cubed. Then what did I do? Then I needed a what? Well, first of all, I turned this into what? X squared of x, like I just showed you a second ago. Then what did I do? Then I got a common denominator by multiplying this by x squared of x over x squared of x. And by the way, what's square root of x times square root of x? What is it? X. Okay. All right, so square root of x times square root of x just turned into x, and then x times that x turned into what here? X squared. And then once I had a common denominator, I just brought them together under one fraction. Okay, so you're going to have to do that on the test on Friday. Everything on here is on the test. Everything. Okay? All right, so after I did 22, you should have no trouble doing 23 and 24. Okay, let's keep going here. Factoring and expanding. You got to know the difference between factoring and expanding. Okay, when you have a difference of squares, a squared minus b squared, you got to know that factors into your a minus your b times your a plus your b. You also have to know how to factor a sum and difference of cubes. Okay, you got to memorize the pattern. What's the pattern? Well, just remember, when you're factoring a difference of cubes, it's a binomial times a trinomial. The binomial comes from what you start with without the powers. That's easy. And then the trinomial comes from the first one squared. And then this sign is always the opposite of that sign. So since that's a minus, that's a plus. The middle term has one of each, an a times a b, right? This is always a plus no matter what. And then what's the last term? Your second piece, what? Square, okay? So if you follow that, it works here as well, doesn't it? The same pattern works here. All right, what's the difference between factoring something like that, or factoring something like that and expanding something like that? What's the difference between those two things? Well, obviously they're two different things. Here you're factoring, right, into a binomial times a trinomial. Here you're what? Expanding it. It's like multiplying a plus b times a plus b times a plus b. Now you could do that the long way, but it'll take you a lot of work. What's the easier way? Well, the easier way is just to memorize the pattern. So what's the pattern for expanding a plus b cubed? Well, just remember it's 4 pieces. The first piece comes from the first one with the power of 3. And then the powers, the signs will alternate, okay? So that's a plus. Now in this case though, just remember when this is a plus, it's always plus, okay? For a minus, then you have alternating signs. But when that's a plus, these are all pluses, so that's easy. So the second term is 3 times the first one squared times the second one, and then another plus. Then another 3 times, this time is the first one times the second one squared. And then finally the last term is just the b with the cube on it. Okay? So it's just a little pattern that makes it easier to expand something like that without going through a whole bunch of work. Okay? So I really would like you to memorize all of these. I'm sure you know that one already. You might already know these two. Those are very close, except that has a minus there. That has a plus. Other than that, they're the same. Okay? And if you forget this one, what's an easy way to do this one if you forget it? Just just rewrite it as a plus b times a plus b, and then FOIL, right? And that'll get you that. Is that clear? Okay? All right, so these are all things you need to know. All right, what's the difference between these two problems? Look at them. What's the difference? This is just what? Adding 2 fractions. This is actually what? Solving an equation. So even though they look very similar, the way you approach them is going to be different. Okay? All right, let's look at the first one. In order to add or subtract 2 fractions, you always need a common denominator. What's the common denominator? Quick. 3x. So what I did is to get a common denominator here, I have to multiply this one by 3 over 3, right? And then to get a common denominator on that one, I have to multiply that one by what? X over x. To get the common denominator of 3x, correct? And once I got a common denominator, that takes me to there, and I just add them together and combine them. I'm done. Done with that one. Okay, how about here? Now, if you want, in order to solve this, you could do what I just did here on the left side and then take it from there. That would work, but there's an easier way. What's the easier way when you need to solve an equation with fractions in it? What's the easier way to handle it? Instead of getting a common denominator, what's the trick? The trick is to multiply everything by what? The trick is to multiply everything by what? By what the common denominator would have been. What would the common denominator have been here? 12x. So if I multiply everything by 12x, look what happens. And simplify, the fractions go away. So isn't that much easier to handle now from there, and you could finish it if you had to? Right? Everybody see what I did? You see the trick there? So here, you're not eliminating the common denominator. You're just getting a common denominator and simplifying. Here, to solve, you can actually eliminate by multiplying by the common denominator and then just go from there. So from here, you could finish it. Yes? Got it? You see the difference between how you handle those two situations? Okay? Good. Okay. When I ask you to simplify or factor something, the first thing you do is look to see if you can pull something out. So looking at those, what do each term have in common? What do the 2x squared and the 8x have in common? They both have a 2 and a what? An x. So I pulled out a 2x and I wrote what was left in parentheses. So what was left over? x minus 4. So that's how you can simplify and factor something like that, right? All right, now, after I did 25, you should have no trouble doing 26 and 27. Okay, 28 is different. Let's look at it. Notice what I did. I looked at it as that whole term minus, I looked at it as that whole term minus that whole term. And what did I do? I noticed they both had a what? An x plus 3 that I can pull out. So that's what I did. I pulled the x plus 3 out front, and then in parentheses, I just wrote what was left over. What's left over? If I pull an x plus 3 out of that, what am I left with? 4x. Bring down your minus. There it is. And then if I pull an x plus 3 out of there, what am I left with? 7. So that's how you can simplify and factor a mess like that. Look for a common factor that you can pull out. So now that I did 28, you should have no trouble doing 29 and 30. All right. Factoring a trinomial. You've got to know how to factor a trinomial by quickly doing some trial and error. So that's what I'm going to do here. How do I factor a trinomial like that by trial and error? Well, first I look at the x squared. Where does the x squared come from? An x and a x. What do the signs have to be if they multiply to a positive and add to a negative? Both negative, so I can fill those in. Where does a 15 come from? Either a 1 times a 15 or a 3 times a 5. Well, by trial and error, when I put them in and multiply those and add them together, I got to get a what? Minus 16x. So do you agree it's got to be the 1 and the 15? Yes? Okay, so that's how you can quickly factor a trinomial by trial and error. So now that I did 31, well, actually I did 31, you should not be able to do 34. 32 and 33 are different. What did I do here? I just what? I just rearranged them and then did trial and error. What did I do here? First I pull out a what? A 3 and then just factored what was left. Is that clear? Okay, so now you should be able to do 34 through 36. Let's keep going, guys. What did I do on 37 here? What did I do? To solve something like that, I first move everything to one side equaling 0. Then what did I do? Factor the left side, and then I use the zero product property. What does that mean? Well, that means when you got a product equaling 0, the product will be 0 when any of the factors is 0. So when is 3x plus 1 going to be 0? Well, you can do it on paper, and you get what? X equals what? Negative 1/3. When is that going to be 0, making the whole product 0? At what? 2. So everybody agree you get your solutions, negative 1/3 and 2? Got it? So now that you did 37, you should have no trouble doing 38. Okay, what did I do on 39? Quick. What did I do? Notice it was a what? Difference of squares, so I factor the left side, use the zero product property, done. Boom. Should be able to do 40 that way. What did I do in 41? I noticed that x to the 4th minus 81 is a what? It's a difference of squares, isn't it? Because I can think of that as being what? X squared, and I can think of the 81 as being what? 9 squared. Isn't that a difference of squares? A squared minus b squared, which can be factored into what? Your a plus your b times your a minus your b. And then from there, that doesn't factor, but that does factor, or you could just leave it the way it is. So what did I do from there? I said, okay, you got a product equaling 0, zero product property. This product would be 0 when that's 0, which is at what? Square root of negative 9, which is undefined, so that doesn't give me any solutions. When is that 0? Well, again, I just undid operations. I got what? What's square root of 9 is what? 3, so I get what for my solutions? Plus or minus 3. Got it, guys? You see how I got my solutions there? Okay, and you can look at the rest of them. Okay, here I pulled out an x, factored, and finished. Pretty easy, right? Okay, so you should have no trouble after I re-explain those. Okay, what did I do here, guys? What did I do? Quick. I pulled out a 4 in the numerator, and then I factored that trinomial, right? Into x plus 1 times x plus 1. Then what did I do? Canceled the x plus 1s, and I was left with that. Just know that in your answer, why can x not be negative 1 in your answer? Because at the original problem, it would have been what? It would have been undefined, right? Because the 0 in the denominator, right? Got it? All right, so that's how you simplify something like that. So now that I did 45, you should have no trouble doing 46, 47. How did I do 48? Real quick. I mean, I typed this up so you don't have to write it down. You can just listen and watch. What did I do on 48? What did I do? Well, I simplified them all separately as much as I could. That took me to here. Then at that point, I just what? Multiplied the numerators together, and then I multiplied the denominators together. That turned that into that. And then I simplified the x to the 6 over x cubed into that. Can you handle that? Okay, so you should have no trouble doing 49. Okay, 50 is what type of problem? Quick, quick, quick. It's a multiplication. Okay, and so what I did is what then? What did I do? I just factored all of these binomials and trinomials, turned it into this mess. Then what did I do? I just canceled a bunch of stuff from numerator to denominator, right? So after I cancel a bunch of stuff, what's my answer? X plus 1 over x minus 1. Got it? Yes? Okay. All right, what's different between 50 and 52? They're similar problems, except now instead of a multiplication, I got a what? Division. So how do you handle that? Well, instead of dividing by a fraction, it's the same as multiplying by its what? Reciprocal. So I flipped this, didn't I? And then it's just like number 50 at that point, right? What did I do? Factored and canceled, got my answer. Can you handle these? There'll be a couple of these on the test on Friday. Okay? Okay, what did I do on 54? Go. What did I do? Since I'm adding, I cannot add or subtract fractions without a common denominator. So isn't that what I did? I got a common denominator here. I'm multiplying that by that and multiplying this by that. Isn't that going to give me the common denominator? Then what did I do? I distributed the negative 4 here and here and here. I distributed the plus 5 here and here, giving me that. Combined like terms. Done. Got it? Okay, so now that I did 54, you should be able to do the next two. Okay, what did I do on 57? What's the difference between 54 and 57, guys? Look for the difference. What's the difference between 54 and 57? You tell me. Go. What is it? 57 is a what? Equation that you need to solve. 54 was just combining and simplifying. Totally different, isn't it? So you could get a common denominator here like I did on 54, but there's an easier way. What's the easier way? What did I do instead? What did I do? I multiplied everything by what the common denominator would have been. So what would have been the common denominator? X times x plus 1 times x minus 1. So I didn't show you all the work, but if I multiply each of these fractions by that common denominator and simplify, I get to here. Then what did I do? What did I do then? I FOILed there to get that, right? What did I do? I FOILed here to get that. Right? And then what did I do from here? From that step, what did I do? I distributed the x here. I distributed the 2 there. I distributed the x squared there. Moved everything to the left side equaling 0, and then I tried to solve it by factoring. And I noticed it didn't factor, so what's your only other option at that point? Quadratic formula. And that's how you get your solutions. Okay? Can you handle that? Okay? So now that you did 57, you should be able to do 58. Okay, 59 through 62 are just more of those things from earlier that I pointed out. You can do those. Let's look at 63. All right. Again, what would I do on 63? I gave you a hint. What did I do? I looked at it as being that whole term plus that whole term. And what do each of the circled terms have in common that I can pull out front? They each have a what? A 2x minus 1 to at least what power? The second power. So I can pull out a 2x minus 1 to the second power and then write what's left over in parentheses and then simplify from there. Is that clear? Okay? All right, so I'm not going to go through those. I'll come back to these when I have time at the end. But I want to at least skim through all 3 packets, and then at the end I'll take your questions. Got it? Okay? Trig. I'll tell you right now, trig is in every chapter of this textbook. You have to be trig experts. I just taught you how to be Algebra 1 and Algebra 2 experts. Now I got to teach you how to be trig experts. Because without that, you won't make it through the course, right? All right, so most of these you already know. You already know that secant is 1 over cosine and vice versa, right? Cosine is 1 over secant. You know all these, right? You know tangent is the same as sine over cosine, and so on, right? You know all those, okay? There's a couple, remember that whole sheet of identities you learned in pre-calc? I'm going to reduce that down to these. Okay, these are the only identities that will come up in here. These are the only ones that you'll be accountable for. Okay? All right, so let me go through. There are 3 Pythagorean identities you need to know. They come up every now and then. You should know that the sine squared of an angle plus the cosine squared of the same angle equals 1. You should know that 1 plus the tangent squared is a secant squared. You should know that 1 plus the cotangent squared is a cosecant squared. There's a whole bunch of double angle identities. There's only one I want you to remember, and that's this. What's the sine of 2 theta, guys? It's the same as what? 2 sine theta cosine theta. Got it? All right, when you're dealing with a right triangle, and you got angles and side lengths and all that, what do you got to remember with a right triangle only? SOHCAHTOA, right? In other words, you can find the sine of any angle in the triangle by taking the what? Opposite side over the hypotenuse. You can find the cosine of any angle by taking its adjacent side over the hypotenuse, and so on, right? Okay, you got to know that. All right, very, very important. Everybody look. These look very similar, but I cannot have you guys confuse them. What's the difference between that and that? Well, just remember this. When I put the exponent between the trig function and the angle, what does that mean? That means the entire trig function is being squared, so you can think of it and even rewrite it as that if you need to understand what it means. Is that clear? What happens when I put the exponent there instead? Well, that means just the what? Only the angle is being squared, so how would you rewrite that so you don't mess it up? I would rewrite it as what? Sine of, in parentheses, theta squared. Do you understand the difference? Do you understand they're not the same thing? You understand that? Okay, that's very, very important. Okay. Unit circle. I'm telling you right now, I don't want you to try and memorize the whole unit circle. And I'm only going to let you use a calculator on parts of my tests throughout the year. Every test this year will have a calculator part and a non-calculator part, beginning with Friday's test. So, there's certain things with trig functions you got to be able to do with a little bit of memorization and a little bit of manipulation without a calculator. Okay, so I'm going to show you right now the things you must be able to do with the unit circle without a calculator. Don't try and memorize the whole unit circle. It's too much. I'm going to simplify that for you. Are you ready? All right, first you got to know what the unit circle is. What is the unit circle? It's a circle with a radius of 1. So what I drew there for you is a circle with a radius of 1. And what I did is I labeled 4 points on the circle, didn't I? Wouldn't that be the point 10? Wouldn't that be the point 01 and so on? Okay, that's the first thing you got to know. Second thing you got to know is that at each point on this circle, okay, at each point on the circle, when you draw the angle theta using any point on the circle, you can find the cosine and the sine of that angle by simply remembering that the x value of those points on the circle give you the cosine, and the y values give you the sine. So if I ask you right now for the sine of pi over 2, well, first of all, where's pi over 2? Well, if I go halfway around the circle, it's what? 180 degrees, which is what? Pi radians. But if I go all the way around the circle, that's 2 pi or 360 degrees. So if I go halfway up like this, what angle are we talking about there? 90 degrees or a half a pi, pi over 2. So then, what is the cosine of pi over 2? It's the x value on the unit circle, which is what? 0. What's the sine of pi over 2? It's the y value there, which is what? Remember, the y value is, remember, it's cosine, comma sine on the unit circle. So what's the sine of pi over 2? What is it? 1. Okay, real quick. What's the cosine of pi? It's the cosine of pi. Pi is this. Isn't this the angle pi right here? What is it? -1. What's the sine of pi? 0. See how easy it is once you just visualize the unit circle? Okay, so there's really not a whole lot of memorizing yet, is there? No. Okay. Here's where the memorizing comes in. There's 3 values I want you to memorize. That, and that. All right, are you ready? Those are the only 3 things I need you to memorize about the unit circle. Everything else you can figure out from there. Are you ready? Okay, just know that when you're at 30 degrees, which by the way is the same as pi over 6, okay? Same thing here. just know that that point right there is square root of 3 over 2 comma a half. So in other words, what's the cosine of 30 degrees? In other words, what's the cosine of pi over 6? That's what? Square root of 3 over 2. And then what's the sine of 30 degrees or pi over 6? You're going to have to memorize that as being what? It's the y value, which is what? A half. And then the good news is, at 60 degrees or pi over 3, they what? They just what? They just switch, right? They just switch. So the cosine of pi over 6, or I'm sorry, the cosine of pi over 3, or the cosine of 60 degrees is a half, and the sine of pi over 3, in other words, the sine of 60 degrees is square root of 3 over 2. So once you memorize those two at 30 degrees, just switch them at 60 degrees. Got it? And then the only other thing I need to you to memorize is that at 45 degrees, or pi over 4, they're both what? They're both what, guys? Square root of 2 over 2. So again, I've only given you three things to memorize, right? A half, square root of 3 over 2, and square root of 2 over 2. Okay, now I'm going to show you how to figure out everything else from there. Ready? Flip the page. Okay, suppose I ask you to find tangent of pi over 6 without a calculator. You better be able to do it. What are you going to do? Quick, quick, quick. You got to know the tangent, first of all, is what? Sine over cosine. So you're going to write that. And then you've got this memorized. What is it? It's a half. You got this memorized. What is it? That. And then what? What's the trick earlier I showed you to clear out the complex fraction? Multiply top and bottom by the what? Common denominator, which is what? 2. And then simplify, you get that. And by the way, don't leave the radical in your denominator. How do I get rid of that radical in your denominator? Multiply top and bottom by what? Square root of 3, and that'll turn it into this, right? So that's your final answer. Okay, good? Can you do that? Again, not a whole lot of memorizing, is there? No? All right, now, what about if you have an angle like 7 pi over 6, which is not in the first quadrant? Well, think about it. Go back to elementary school when you were plotting points. Is an x positive over here and here? Is an x negative here and here? So isn't that the same thing with cosine of theta? Cosine of theta would be positive here and here. Cosine of theta would be negative here and here, wouldn't it? Okay, let's talk about the y values. Y is what? Positive where? Here and here. So guess what? Sine is positive here and here. Where is the y values negative? Here and here. So where is the sine negative? Here and here. Understand that? Okay? So then, what would you do if I asked you to find the sine of 7 pi over 6 without a calculator? Well, you're going to do a couple things. First thing you're going to do is say, well, let's see, 7 pi over 6, that's 1 and 1/6 pi, isn't it? Isn't 7 6 pi, or 7 pi over 6, 1 and 1/6 pi? So where do you land if you go 1 and 1/6 pi starting here? Well, you go a pi there, and then a 1/6 of a pi lands you where? Third quadrant. Okay? All right. In the third quadrant, is the sign positive or negative? Negative. So you know you better have a negative answer. That's where that came from. And then what you do is you figure out the reference angle. What I mean by the reference angle is you take the little piece of the pie that goes to the nearest x-axis. So what's the piece of the pie in here? Going to the nearest x-axis. What's a little piece of pie in there? Pi over 6. So what is the sign of pi over 6? What is it? You're supposed to have it memorized. 1/2. So what's the answer here? Negative 1/2. You see how you can figure out everything from there? Yes? So don't try and memorize the whole unit circle. Just memorize those three values, and everything else you can figure out from there. I'll tell you right now, if you don't know how to do this, what I just showed you, you will get 4 or 5 problems wrong on every test the rest of the year, just on this. Just on this alone. Okay, so you got to know how to do this. You guys, hang in there. I'll give you a break after this packet, before I go to packet 2. All right, so you should now be able to go through and do all of these without a calculator. Okay, now there's a bunch of stuff you got to know how to do on the calculator, and here it is step by step. If I have time at the end of the hour, I'll maybe do one of these, but I think it's pretty self-explanatory that you read these 2 pages and then do 74 through 80. Got it? Okay? All right, and then there are your answers to the whole packet. All right, so just take a stretch break, just 1 minute. Get up and stretch, because we got a long way to go, guys. Still got about another 50 minutes, so get up and stretch, please. I don't want to lose you guys. Yeah. I don't know if they gave me a pass yet. Huh. I don't remember getting a emergency pass. Or a hallway pass. I had more time. Okay, let's look at packet 2. We're just going to, again, flip through this as quickly as we can. I can't go over everything, but I'll try and do the best I can. Okay, here we go. Okay, intercepts, domain, symmetry, those are all pretty self-explanatory. I think you can figure this out. Yeah, again, I think this is all pretty easy Algebra 2 stuff. If you read my examples, I think you can figure that out. Same thing here. One thing I want to point out from this page, I don't want you to use y equals mx plus b this year when you're writing equations of lines. So I don't want you to use y equals mx plus b. Instead, I want you to use what? Point slope form. And here's an example of how I did that here. Now the good news is once you have point slope form, you can get the other forms from there, can't you? So once you write the point slope form, what can I do? I can distribute, right? And move everything, well, put it in y equals mx plus b form, and I've got slope intercept form. And then from there I can clear out the fractions and move things around to get general form or standard form. So if you always start with point slope form, which I want you to do, you can always get the other two forms if you need to. But there's going to be some questions on the AP exam that will just let you stop right there and just use that as the equation of your line. Is that clear? So from now on, when I ask you to write an equation for a line, you're going to use what? Point slope form. Okay, flip the page. Okay, this stuff is pretty self-explanatory. I'm not going to go over that. All right, now, you guys, you better memorize these basic functions without a calculator. You should know what a basic quadratic looks like, a basic cubic, a basic rational, a basic square root function, a basic absolute value. You should definitely know what the basic sine and cosine look like. And then from there, you're going to have to move them, flip them, transform them, and do all kinds of stuff based on changes to the basic function. And that's what I'm going to go over now. Are you ready? So once you've memorized these, this is what I want you to be able to do with them. Ready? Okay, what happens if I take an original function, I add something on the outside? What happens? If I add a constant on the outside, the original graph does what? Moves up by c units. What happens when I subtract something on the outside of the function? Everything moves down c units. What if I add something on the inside of the function with the x? Then everything moves to the left c units. How about when I subtract something inside the function? Everything moves right c units. What happens when I multiply by a negative inside the function? What happens to the original graph? It flips over the y-axis. What happens when I multiply by a negative on the outside? It flips everything over the x-axis. Think about that one. That one's common sense, right? If I put a negative out front, all the old positive y values become negative. Makes it flip downward, doesn't it? So that's the easy way to memorize that one. Is that clear? Okay. What happens when I multiply a function by a number a that's bigger than 1? It makes all the old y values what? Bigger. Which should take something that might have looked like that. If it makes the y values bigger, now it becomes what? Makes everything rise more quickly, which in that case would make it skinnier. What happens if the number out front that you multiply by is between 0 and 1? Doesn't that make all the old y values smaller? So something like this, what would happen? The y values would get smaller, making it grow more slowly, making it wider in a situation like that. Do you understand how to use common sense there? Okay, now, let's do a bunch of them then. Before I get back to that, please know how to do example 6. It's the only one like it, and there is one like that on the test. What did I do? If I say find g of 3 minus f of negative 2 plus 5, what in the world do I do? If I give you a graph of g of x and f of x, what are you going to do? What are you going to do? You start picking out values. How do I pick out g of 3 from the graph? I just find the what? The y value on g when x is 3. So here's x equals 3 right here, isn't it? What's the y value right there? 2. So I replace g of 3 with what? 2. And then do the same thing with f of what? Negative 2. How do I find f of negative 2 on the graph? I find the y value when x is negative 2. So looking at the graph of f now, when x is negative 2 over here, what's the y value up here? 4. And then just go from there. Is that clear? Yes? All right. And then, B is pretty similar, but this time I'm doing a composition. When I have a composition, I always work from the inside out. So first I would find what here? F of negative 1, which I did. What's f of negative 1? Negative 3. And then this problem turns into g of what? Negative 3. And then I just pick out g of negative 3 from the graph, and I'm done. Is that clear? This you can come back to after I go over what I'm going to do next. Are you ready? Okay. What's that? Oh, you have a question? Oh, okay. All right, so what did I do here? First of all, what's the memorized parent function? I'm going to ask you to graph a whole bunch of these like this on the non-calculator part of the test on Friday. So you're going to have to be able to do a whole bunch of these on Friday. They're actually pretty easy once you get the hang of it. So what did I do here? If I ask you to graph something like that on Friday's test, what's the first thing you're going to do without a calculator? You're going to recognize that what's the parent function? What is it? Y equals x cubed is the parent function, which you should all have memorized. Looks like what? Goes through 0, 0, and goes like this, doesn't it? Isn't that what the memorized cubic function is going to look like? All right, what changes are happening here? What changes are happening? You got a minus 2 on the inside and a minus 2 on the outside. Which one do you do first? Well, you follow PEMDAS if you're not sure. So you should handle the inside one first. So what happens to that memorized graph when you subtract 2 on the inside? It moves 2 to the right. So this point moves to here, doesn't it? Yes? Okay, not done yet. Then what? What does minus 2 on the outside do to everything? It moves everything 2 down. So now, after moving 2 to the right and 2 down, the point that started out there will now be here, won't it? But then the rest of the graph will look the same, right? So just draw something that looks like that, and that's your answer. Can you handle something like that on the test? Yes? Pretty easy, right? But you got to memorize what the cubic function looks like, right? Okay. All right, so now that you did that, you should be able to do a bunch of these other ones. Oh, but this is a tricky one. How in the world are you going to handle that absolute value on the outside? What's the parent function here? The cubic or the absolute value? What's the parent function? You always work from the inside out. So what's the parent function? Cubic. Okay, so you're going to start with the cubic function, right? Which we all know what it looks like. What's the plus 2 inside the cubic function do to it? Moves everything 2 to the left. Okay, so you can visualize what that looks like, right? Wouldn't that look like this? So moving everything to the left. Won't that look like this? Yes? All right, but then along comes the absolute value and does what? What does absolute value do? Learned it back in elementary school. What does absolute value do? It makes everything positive. So anywhere where this graph is negative, you got to make it what? Positive. So you're going to take this negative part of the graph and what? Flip it what? Up. And so your final graph, right? So that's going to go away and it's going to be made positive by flipping up. So your final graph there is going to look like that, isn't it? Do you understand what I did there? Yes? Can you handle that? Okay, there will be one like that on the test on Friday as well. Be ready for it. I expect you to know all this stuff. Okay, 8 and 9 are pretty easy. Flip the page again. Okay, piecewise functions. Do not be afraid of piecewise functions. Do not panic. I'd say 2 out of every 3 years there's a free response question with a piecewise function. And they're going to come up throughout the course. So you got to know the basics of how to handle a piecewise function. What's a piecewise function? It's 2 or more functions put together with certain conditions, yes? So there's an example of a piecewise function. I would expect you to be able to graph that on the test. Ready? So what do? Well, you take it one piece at a time. What's the first piece? Well, you got y equals what? X squared minus 1. And what type of graph is that? It's a parabola. But you only keep the piece of the parabola for x values that are what? Less than 2. So what did I do first? I graphed the parabola y equals x squared minus 1, which you should all know is just that parabola shifted down 1 like that, right? And notice what I did. I erased the part of the parabola that I don't want. So I only kept the piece of the parabola where x is what? Less than what? X is less than what? 2. And by the way, there should be an open circle there, yes? Got it? Yes? And then what's the other piece? The other piece of the function is y equals what? 1/2 x plus 2. What is that? That's a line. So I just graphed the line, y equals 1/2 x plus 2. There's the line right there, but I only kept the piece of the line where x is what? Greater than or equal to what? 2. Do you agree then? I drew a line, but I only kept the piece of the line where x is greater than or equal to 2? Yes? And then I just what? I put the 2 together and I got my final answer. So aren't piecewise functions easy? Now, they're not always going to come together like that. Sometimes they're going to be, disjointed, right? It's going to be broken, right? I mean, they're not always going to come together like that. Is that clear? But in this case, they just so happen to come together. Okay? Can you handle a piecewise function on the test on Friday? Yes? Okay, good. Next page. Okay, when I ever ask you to find the domain, instead of trying to, well, what is the domain? That's all possible x values. Instead of trying to figure out what x can be, it's usually easier to figure out what x cannot be. Okay? Heads up? Okay, so what am I going to do? Well, the first thing I'm going to do is change tangent to what? Sine over cosine. Then it becomes obvious what to do from there. What can x not be? Any value x that would make the denominator what? 0, because that would make the whole thing undefined. You agree x cannot be that? Okay, so when is cosine 0? Think of the unit circle. Where on the unit circle is the cosine, which is the x value, 0? Where? Here. So x cannot be what? Pi over 2. What else? 3 pi over 2. And if you keep going around the circle by adding another pi, what's the next one going to be? 5 pi over 2, 7 pi over 2. Basically, to get from here to here, you got to keep adding or subtracting a pi, correct? So how, and by the way, you can go in a negative direction as well. Isn't this the same as negative pi over 2? Isn't this the same as negative 3 pi over 2 and so on? Yes? So how can you generalize that answer? By saying all reals x not equal to what? The domain is all reals x not equal to what? What is it? Pi over 2 plus what? And pi, where n can be any positive or negative what? Integer. Wouldn't that formula cover all of those answers? Wouldn't it? Okay, so you might have to do something like that. Just generalize your answer. Okay. Okay, am I done with packet 2? Yes? Well, that's good. Again, I will come back to these and take some questions at the end of the hour, but I just want to get through all of them first. Okay, packet 3, that's this one, right? Okay, everybody got that in front of you? All right, again, I can't read line by line. There's no time for that, so I'm just going to skim through and highlight some stuff. Are you ready? Okay, what's the first thing you need to know about f? And by the way, that's called the inverse function. Even though it looks like the negative one is an exponent, it's really not. Don't think of that as an exponent. That's just how we write the inverse of a function. Is that clear? All right, so what's the relationship between f and its inverse function? Well, a couple things. Basically, the easy thing to remember is you just switch the domains and ranges. You switch all the x and y's. So if x contains the 0.5, if f contains the 0.52, then f inverse will contain the point what? 25. That's the easiest way to remember what the relationship is. Okay? Now, a couple other things you should know. When you take the composition of f and its inverses both ways, after you simplify those, you should always get what? X when you simplify it. That's one thing you should know. Okay, here's another way to write it. Okay, if f and g are inverses, that's saying the same thing. Okay, so here's an example of that. Notice when I took f of g of x and g of f of x, I got what in each case? What did I get? X. Okay, no big deal. E is pretty easy. I'm sure you all remember how to take a function and find the inverse from Algebra 1. I know you remember this. I teach this to my Algebra 1 kids. Okay, there's a step-by-step process on how to take a function and end up with its inverse. You can read that later. That's pretty easy. Okay, now, and again, there's an example of what I just said on how you take a function and go through a couple steps and you end up with the inverse function. So, according to what I just did, these two functions should be inverses of each other. So there's a couple things you need to know graphically about f and its inverse. Are you ready? Well, here's f, right? It's just a cubic function shifted forward to the right. I just drew a rough sketch. But what happens when I graph its inverse? What is y equals x squared plus 4? That's a what? It's a parabola. But wait a minute. F and its inverse are supposed to be reflections of each other over the line y equals x. You see that dotted line y equals x? So this is what f inverse should look like, because isn't that the reflection of f over the line y equals x? Isn't it? Isn't it, guys? So what do I got to do to my answer here? I got to say, I got to cross out that piece and only keep this piece. In other words, I got to say the domain is what on my answer? The domain is all x's greater than what? Greater than or equal to 0. So basically, I got to cross out that piece. So that's how I got these domains and ranges down here. Is that clear? Yes? Just remember, f and f inverse have to be reflections of each other over what line? The line y equals x. Okay, that leads me into my next concept, which is huge. What I'm about to show you is going to be about 10 questions on the test on Friday. So you better, at least 10, maybe more. Are you ready? You ready? I'm going to fly through this. You got to pick up on all of it. Okay, I'm going to highlight stuff, and hopefully you're going to get it from there. All right, ready? All right, I want you to memorize what the graph of f of x equals a to the x looks like. It goes to the point 0, 1, and then kind of rises from left to right, and the x-axis, by the way, is a horizontal asymptote. Now, so what am I saying by that? Well, let me make it easier for you. Are you ready? If I ask you to roughly graph that, or that, or that, those all look the same. Not exactly the same, but they all have the same features and shape, and you can get a rough sketch all the same way. Are you ready? Okay? And by the way, if you don't know why E works, E is just a number. E is like 2.72, so doesn't that fit the same form if you think about it that way? Yes? Okay. So when you have y equals a number raised to the x power, what does that graph look like without a calculator? You're going to have to know. Ready? All right? You all know what 2 to the 0 is, or 5 to the 0, or e to the 0. Anything to the 0 power is 1. So what I'm saying is, you should all know that these graphs all pass through the point 0, 1. Got it? All right, now let's look at it. The bigger I make x here, what happens? the bigger the y value. And so just know that it grows gradually like that, from left to right. Got it? And the bigger you get, the steeper it gets. Got it? And so it just rises gradually like that. Common sense, right? I haven't made you memorize anything yet, have I? It's common sense. All right, now what happens when I put negative values in here for x? Like, for example, like if I put 5 to the negative 3 power, right? So if I plug in a negative 3, that becomes 1 over 5 cubed, which is 1 over what? 125? So what happens as I go to the left? The y values, what? Get smaller, and they go like this, right? So the more negative I make it, the smaller these values are going to get. And so it's going to keep falling and falling and falling that way. Is it ever going to hit 0? Is there anything you can put in there to make any of those equal 0 and touch the x-axis? No. So what does that mean? There's a what? There's always a what? Asymptote on top of the x-axis. So again, have I made you memorize anything? No. Is it easier now that you understand where it comes from just to memorize it? Yes. So just remember, it goes to the point 0, 1, horizontal asymptote on the x-axis, rises from left to right. Boom, you got it. Okay? Now, what happens if I start asking you this? What if I put a +1 on the inside? What's that going to do to the memorized graph? It's going to move everything 1 to the left. So that point's going to move 1 to the left. Is the asymptote going to change? Nope. So you're just going to move that point 1 to the left and then just recopy it the same way. Got it? What if I do this to you? What if I put a +1 on the outside of the function like that instead of in the inside? Now what is it going to do to the memorized graph? Everything's going to move up 1. So which means this point moves up to 0, 2. And what about the asymptote? It moves up to where? Yeah, so you're looking at what? You're looking at an asymptote here, right? You're looking at the point there, and then the rest of it's going to look like that. Yes? Everybody agree that that's what that's going to look like? Yes? Can you handle this? I'll give you a bunch of these on the test. Okay, what if I put a negative out front of one of these? Is that going to change the asymptote? No. But it's going to, instead of rising from left to right, it's going to what? Fall from left to right. Is that clear? Yeah? Can you handle those now? All right. Good. Oh, don't flip the page yet. These are just some basic properties. Those are just Algebra 1 properties, aren't they? You already know all those, don't you? Okay, so flip the page. And what did I say? E to the x, y equals e to the x works the same way. So that looks the same as what I was just going over. Yes? Got it? Okay, properties of exponents, again, those are Algebra 1. Very easy, right? Okay. And again, from the memorized graph, you can figure those out, can't you? Yes? Okay. All right, here's an example. If I ask you to graph a mess like that on Friday's test without a calculator, what are you going to do first? Well, the first thing you're going to do is rearrange it in a more familiar order, and then it's more clear what's happening. Do you know what the basic parent function is? Yes. What's the +1 inside the function do? Moves everything 1 to the left. What's the -3 on the outside do? Everything 3 down. So the point that's normally at 0, 1 moves to what? Well, basically it moves, first of all, moving it 1 left and down 3 moves it to there, yes? What about the asymptote? The asymptote got moved 3 down from the x-axis, so does the asymptote move down to there at -3, right? But you see what I did? And then from there I just what? Redrew the memorized graph to get this as your final graph. But you see what I did there? Okay? Does this help? So now you guys are going to be trig experts, algebra 2 experts, basic function experts. Yes? Yes? All without a calculator, right? Oh, and you're going to be calculator experts too, right? Okay. All right, there's some more for you to look at. I can't go through all of them. Okay, now, we're going to switch from this we're going to switch from functions like this. Whoops, sorry. We're going to now switch our focus from functions like that to functions like this. All right, now, a couple things I want you to know. about these. Okay, I just talked about those a whole bunch. Now I'm going to talk about these a whole bunch. Ready? A couple things I want you to know. First of all, if you don't know what, first of all, this is a sloppy ln. Sorry, guys. That's ln, natural log of x. If you don't know, this might help. Okay. That means I'm talking too much. Okay. Natural log is the same as log base e of x. So by looking at it like that, these really are going to look very similar. Okay, so natural log of x is going to look very similar to log base 2 of x, or log base 3 of x, or log base 4 of x. Their graphs are going to, again, look very similar. Got it? Because, again, natural log of x just means log base e of x. So these are basically the same thing. Instead of 2 there, you got a what? E, which is like 2.71. So you agree they should be pretty similar graphs? Yes? Okay, here's the other big thing I need you to know. These are inverses of each other, and these are inverses of each other. So what does that mean? So if we all know what this looks like now, or that looks like, how are you going to get the graph of those? Reflect them over the line y equals x. So if I ask you to draw what y equals natural log of x looks like, or log base 3 of x looks like, what are you going to do? You're going to take what? These graphs, which go through what? 0, 1, and make it go through what? 1, 0. And instead of there being a horizontal asymptote on the x-axis, there's now going to be a horizontal asymptote on the what? On the what? Y-axis. And guess what? The rest of it's going to look like that. Isn't that a reflection of those graphs we were drawing a minute ago? Isn't that a reflection of the graph we drew a bunch of times over the line y equals x? Isn't it? Okay, so now you should memorize what that looks like. Right? And by the way, what can you get from this graph? What's the natural log of 1? 0, because of that point. What's the natural log of 0? Undefined, because of the asymptote. You understand how you can kind of get stuff from this graph? Yes? Okay, but anyway, memorize that, or at least be able to reflect the other memorized graph. Yes? Okay. And now again, what would happen if I start adding and subtracting numbers and multiplying? This graph is just going to what? Shift or flip or whatever. I don't have to do any of those. Do I? Do I? No. Okay, but there are other things you need to know about logs. And let me point those out right now. Okay, first of all, you got to know all these properties. And by the way, I'm going to point them out for log base A, but they work the same exact way for natural log. Log base A of 1 is 0. Well, how do you handle a log of a product? You can write it as a what? Sum of separate logs. How about the log of a quotient? How can you rewrite that? As a difference of the logs. If you have a log of something to a power, what can you do with that power if you'd like to? Bring it down and multiply it out front. These are just simplifying properties you need to know. You do need to know those. Absolutely. Okay, another one you need to know. If you have a raised to the log of the same base a of x, everything just goes away and you're left with the x, whatever it is. Okay, whatever's in that x spot. Same thing here. If you have the log base a of same base a to some power, it just simplifies to the power. Got it? Got to know those. All right. This is something you should also know. You should be able to rewrite that without log. If I give you something like that and I say, please rewrite that equation without a log, how would you do it? Well, you would say, you would take the base and make that your base, raise it to whatever's over here, so raise it to the c power, and then set it equal to whatever's in the p spot. So you can always take something like that and write it without a log as that. So that's one way you can solve log equations, by rewriting it without the log, using that little trick. Do you understand? Okay? All right. So with these new properties and tricks, you should now be able to solve these log or exponential equations without a calculator. Ready? Okay, so there'll be a bunch of these on the test. I'll give you something like that, exactly like that on the test, and I'll say solve it. What are you going to do? Because I'm not going to let you use a calculator. What's one way you can do it, guys? Well, one way is to use a little creativity and realize that you can get the x out of the exponent by doing what to both sides? What did I do? I took the what? Log base 3 of both sides. I can do that. As long as I do the same thing to both sides, I can do that. And so by taking the log base 3 of the left side, this whole mess turns into just what? X. And now in this, I've got to evaluate that some way, somehow. So here's what I did. First of all, I know that 81 is 3 cubed. And can I write 1 over 3 cubed as 3 to the negative third? Isn't that the same thing based on a bunch of stuff I went over at the beginning of the hour? And then what happens when these match? What's the property up here tell you? When those match, it all turns into what? Just what? Just x, which in this case is what? The negative 3. Boom, you're done. That's one way you can do it. What's an easier way you could have done that? Well, at the beginning, you could have just realized that 81 is what? 3 cubed, then I can write 1 over 3 cubed as 3 to the negative third. And what does common sense tell you if you've got an equation with the same base? The exponents have to be what? If you got this equaling this and they have the same base, then the exponents must also be what? Equal. So common sense tells you that x has to equal negative 3. It's up to you. I don't care which way you do it. Either way. Shoot. That should be a 4, shouldn't it? Sorry, guys. So that should be negative 4. Thank you for catching that. Sorry, guys. Yep, you're right. My mistake. Okay. Agree it should be negative 4? Yes? Not negative 3? Same thing over here. Yes? Yes? Sorry about that, guys. Okay, there it is. All right. Now, what's the trick going to be here? What's the trick? Raise up each side as a power with a base of 2. Why would I want to do that? So I can use which property? Which property will help me there? Property 5. So by recognizing that I can use property 5 here, what I did is I raised each side as a power with a base of with a base of 2, I should say. And by doing that, this whole mess turns into just what? X. Yes? And then that I know how to handle. That's just 16, yes? So I get 1/16. That's one way you can do it. What's another way you can do it? Well, remember I said there's this little trick here, number 7, on how to rewrite a log equation without the log. So what's the little trick? How can I take that and rewrite it without the log? I can rewrite it as what? 2 raised to the what? Negative 4 power equals x, and then from there I can write 2 to the negative 4th is 1 over 2 to the 4th, which is 1 over 16. So again, 2 different ways to get the same answer. I don't care which way you do it on the test. There's probably even another way. Who knows? Right? Got it? I don't care how you do it. Just get it right. All right. All right. So I kind of, on part C, it's kind of one step further. What I did is I wrote 25 as 5 squared, so that basically everything canceled out, and this just turns into 2. And then from there, I moved everything to the left side. Then what did I do? Factored and finished. Pretty easy, yes? Okay, this is what I was talking about earlier. You should know what the basic graph of y equals log base 4 of x looks like. And then what does the minus 2 do? Moves everything 2 to the right. So the point that would have been at 1, 0 gets moved to there. The asymptote that would have been on the y-axis gets moved to there. And so I just recopy the memorized graph just like that. Is that clear? All right, everybody take out your calculator. This is where you see if you have the new program or not. If not, you're going to need to get the new program from me. Okay? Oh, wait, before I do F, sorry, let me back up and do E real quick. Ready? Let me do E. You're going to have to simplify this without a calculator. There'll be a couple like that on the test. Everybody look. What did I do? Well, what I did is I recognized that I've got a difference here of logs. And so by realizing that, I think back to the property that said log base A of x over y can be written as log base a of the numerator minus log base a of the denominator. So by realizing I can use that property, I'm going to go backwards and turn something that looks like that into something like that. And so what can I turn that into then, guys? Using this memorized property backwards. I can turn that into what? By the way, these properties work for natural log as well. Is that clear? All right, so what can I turn that into? Log base 2 of what? Yeah, 24 over 3, which is 8. Yes? And then once I do that, I can get creative and turn the 8 into what? 2 cubed. And then once the 2's matched, everything goes away and my answer is what? 3. Okay? Can you do something like that without a calculator on Friday's test? Yes, you can. Okay, now, something like this, which you will not be able to get without a calculator, I will let you use a calculator on. The question is, how do you punch that in correctly? All right, so everybody look at your calculators. All right. This is how you know if you have the new program or not. If you hit alpha and then start hitting like the y equals key, or hit alpha window, or hit alpha zoom, these other options should be popping up. If they're not popping up on your calculator, you need a new program. So just see me at some point, and it'll take like 10 minutes for me to update your calculator. Okay, so you should get those options. So if you hit second window, whoops, sorry, not second window, say that again. Alpha window, I should say. If you hit alpha window, let me just clear everything out. Whoa. Let me just clear it. Okay. So if you hit alpha window, you get these options that pop up. So if you choose option 5, that'll allow you to just fill in the blanks and type in something like this. Get your answer. Is that clear? Yes? Okay. All right. Now, again, guys, here what I did is those properties I went over again, they hold true here as well. Okay? And so you can think of natural log as log base e, right? So you can rewrite that like that. And then you can use that trick I showed you a few minutes ago. Rewrite this as e to the x equals whatever's sitting there. And so that's how you can turn that into that. Okay, so these are the same thing, which is the same thing as this. All three of these things are the same thing. Okay? And then there's those properties again, right? They hold true for natural log. What's the graph of natural log look like? Same thing as like y equals log base 2 of x. Same thing, right? They all look the same. Okay, and then again, so what would be your trick to solve something like this? How could you get rid of that e to get the x out of the exponent? What would be your trick here? Take the what of both sides? Take the what? Natural log of both sides. And that natural log of e to the x plus 1 turns into x plus 1. From there you just subtract 1 and you're done. Okay? What's the trick here to solve that? How do I get rid of the natural log? What's the trick? Raise up each side as a power with a base of e. So doing that, the e and the ln cancel out, getting you to here. And then from there, it's just algebra 1. You with me, guys? Okay, here, that might come up, but you can read it. I would read it. Okay, it is on there, so I do want you to at least look at it. Okay, and then again, this rough sketch stuff I'm not going to go through. Again, what did I do here? I rewrote it as what? I turned the square root into a half power, and then by the log properties, what can I do with that half power? I can bring it down. Okay, what did I do here? I had the natural log of a quotient, which I turned into what? The natural log of a what? I'm sorry, I turned it into a what? Difference of natural logs. Then what did I do? Well, natural log of 6x is a log of a product. What can I turn the log of a product into? A sum, right? So I turned that into the log of 6 plus a natural log of x. And that's how I got my simplified answer. Are you with me? Yes? Okay, next page. Okay, what did I do with this mess? Quick, quick, quick. What did I do with this mess? I noticed it's a natural log of a quotient. So what did I do? I split it up into a what? Difference. Then what did I do with that 2? On that exponent, I what? Pulled it down. What did I do over here? I noticed I had a natural log of a product. So what did I do? I wrote it as a what? Sum. And then I distributed the minus. Then what did I do? I changed the cube root into a what? A 1/3 power. Then according to your properties, what can you do with the natural log of something to a power? You can bring down the power. You're going to have to do one like that on the test on Friday. Is that clear? Here I kind of did the same thing, but I did it backwards. Okay, you guys, I don't have time to go through this arc stuff. But I do want to point out one thing real quick. Sine and arc sine or inverse sine are inverses. So when I take the composition of sine of arc sine, what happens? I end up with just x. Same thing with all the other ones, okay? I wanted to point that out. So that's what I did here. What was the trick? I took what of both sides, guys? I took the what? Took the what? Tangent of both sides. That got me to here, which means the tangent and arctangent canceled out. And then using your unit circle, what's the tangent of pi over 4? 1. Okay? So I replaced the tangent of pi over 4 with 1, and from there I just finished giving me my final answer, which is x equals 2. Okay? All right, so basically a lot of these problems are just a combination of things I taught you today. All right, now you guys, another thing. I'm done with the packets, but before you ask me questions, which I probably only have 5 minutes left, let me point out something that came up in the homework that's going to keep coming up and will come up, I believe, if I'm not mistaken, on Friday's test. Okay, it was the one in the book that you had to do over the summer was more complicated, but it was something related to this. Okay, first of all, from pre-calc, you should all know what that graph looks like. What does that look like? It's a circle with a radius of 3. Now, suppose you didn't know that and you needed to produce that circle on your calculator. Suppose it was more complicated than that and you wanted to graph this on your calculator. What would you do? Solve for y. Right? You'd get that. Don't forget, when you take the square root of both sides, you're supposed to put a plus minus. Okay, so how do I enter that onto my calculator? Well, it's simple. In y1, you type in the positive square root. In y2, you type in the negative square root. So doing that, there it is. Just type it in like that. Okay, and then by the way, when I'm doing this, I mean, you could use a standard window, but it's not going to look right. I like to use either the decimal window or the square window. Let's try the decimal window here. So hit zoom Z decimal. There's the top half of the circle, which is the positive square root. And there's the bottom half of the circle, which is the negative square root. Between the two, you got the whole circle. So you should be able to do something like that and enter that into your calculator for graphing purposes. Is that clear? Okay, you guys, I'm telling you, there's a calculator part. On Friday's test should be the easiest part of the test. But you've got to go through all those steps I showed you earlier. Where was that? Packet 1, I think? Was it packet 1 or packet 2 with the step-by-step stuff on the calculator? Packet 1? Please go through and do at least that one example I gave you. Okay? Now, again, all this is due at the beginning of the hour on Friday, and you got your test on Friday. But I've got 5 minutes. I wish I had more. Or wait, or does this go longer now? It doesn't end at 10:27 anymore, does it? 10:30 exactly? All right, well, we got 10 minutes. That's much better. Okay. All right, so let me get some clean paper here. Okay. Shoot. Yep. 19 on packet 3. Weren't there a couple 19s? What page? Page 62, number 19. Okay. Yeah, there might be one like this on the test. I don't remember. Okay. Well, first of all, they give you this as the function. Whoops. They give you that as a function, and they basically want you to find this minus this all over h, correct? Okay, so here we go. We're going to do this one piece at a time. Are you ready? Where are my colored pencils? Okay. All right. All right, let's find this piece first. Ready? What does that mean to find f of x plus h? That means replace x with what? X plus h. Okay? minus, what's f of x? F of x is just what? 5 to the x, correct? All over what? H. You with me? Okay. Using algebra 1, what can I split that up into? 5 to the x times 5 to the what? H. Because remember, going backwards, when you multiply those 5s, wouldn't you add the exponent going backwards? So if you don't see that, just think backwards, yes? And then minus what? 5 to the x. And then what can you pull out of that minus that? 5 to the x. What does that leave you with? 5 to the h minus 1. All over what? H. Is that what you were trying to show? There you go. Okay? Got it? Good? All right, what else? Keep going. Keep asking. Keep asking. What? Someone say 12? No? Oh. What else, guys? Yeah?
51 on page 74.
What packet?
The third one.
Third one? Oh, well, you got, oh wait, 74, not 76. Wait. Wait, did you say page 74?
Yeah, it's on 76.
Oh, page 76, okay. Okay, 51. Was there A or B or both or what?
B.
B. Okay, let's look at 51B here. All right. Now, I know you're tempted to raise each side up as a power with a base of e so you can use that one property. But you can't do that with a sum there because you won't be able to split it up. So I know you're tempted to do this right now, but you'll be kind of stuck because you won't be able to get rid of both of those logs. So you can't do that yet. So what are you going to do instead?
Good morning, and excuse the interruption. This is an announcement for students who have Mrs. Bellows for their A-Day third block. Students in Mrs. Bellows A-Day today, third block, you have C lunch. So after passing time today, you're going to proceed to your third-hour class and then move on to C lunch today. Again, Mrs. Bellows A-Day, third block, C lunch. If you have any questions, see Mrs. Bellows or Mr. Shell. Thank you very much. Have a great day.
Okay, everybody see what I did? I used the one property that allows you to write that as that going backwards. Yes? Now can I do the trick where I raise each side as a power with a base of e? Yes? So I'm raising each side up now as a power with a base of e. And e raised to the natural log of anything becomes the anything, doesn't it, at this point? Okay, and then e to the first is just e, and then what you can do here is distribute. Move everything to one side equaling 0. Now obviously that's not going to factor, so you're going to have to use a quadratic formula, right? So just use the quadratic formula now to solve that. Does that make sense? Yes? Okay. All right, so there's that. Okay, I don't have time to finish it. Okay, what else? Keep going. Keep asking. Yep. Page 62, number 17. Okay. I did this last hour, so I'm just going to put it up to save some time. So here's what I did, guys. Ready? All right, there's the problem. You got to write the equation y equals c a to the x. In other words, you have to find the value of c and find the value of a in order to be able to write the equation for that graph. Is that what they're asking you? Okay, so you really don't have anything else to do except start plugging in the points. So I'm going to replace x with 1. At the same time, I'm going to replace y with 6. Okay, so that gives me that. And then I'm going to do the same thing with this point. I'm going to put this point into here by replacing y with 24. At the same time, I'm going to replace x with 3. So basically, that gives you two equations, right? Which, by the way, simplify to that. And so basically, it becomes an Algebra 1 question. You got a system of two equations with two variables. What's one way you could solve that? Using substitution. So you can solve for either C or A and then substitute into the other equation. I think I did it one way and it was complicated, so I backed up and I did it the other way. So I think it works out nicely if you solve this equation for C. So I divide both sides by A, giving me that. Then I substitute that equation into here, giving me this. I simplify, and I'm able to figure out what A is. And then once you have A, you can plug A into here and get C. So it's just basically a system of two equations with two variables. You got to piece it together. Does that make sense? Okay? All right. Maybe one more. One more question? Guys, just do as much as you can do. I mean, if you do the whole package, I think I gave you enough examples for you to be able to figure all this stuff out on your own. There will be a curve on the test. I don't know how much. Okay? The good news is it's multiple choice. So you'll be okay. I know it's a lot of stuff, but most of it you already know, I hope. Okay? I wish I had more time, but I don't.